Hello everyone, this is another Bitcoin related tutorial. Today I'm going to show you how to set up a Lightning node on Windows. I know a lot of people run their Bitcoin node on Windows because Bitcoin Core and Bitcoin Knots both make it very easy to install on Windows. And so people sort of starting out on the journey will often set up their full node that way initially. And then they might want to get into setting up a Lightning node and learning how to use Lightning. The problem, of course, is that Lightning doesn't have an easy way to set up a node on Windows. I've created a couple of utilities to make the process a lot easier. I basically got it down to 6 or 7 steps. And the 2 most difficult steps, I've written some automations to make those easy. So I'll go through the process. Before I do that, though, I kind of want to describe a little bit about Lightning. I'm assuming a lot of you watching this video are probably new to Lightning, and so some of the terminology I'll be using and then sort of how it works. If this isn't new to you, then you can skip over this part. But to do this description, I'm going to use this abacus. This is probably the best way to think of the Lightning network. And you have the concept of a Lightning node and Lightning channels. And so you can think of your node as being the hub with some spokes coming out, and the spokes are the channels, right? And so if you think of in the terms of this abacus, each of these rows with beads on it would be a channel, and they'd all be coming out of your node. At the other end of the channel are other nodes, and so you have your node, a bunch of channels connecting to you to a bunch of other nodes. And so I just put some, these might not all be real nodes, I just put some examples like voltage, async, river, bolts, etc. These are basically other people running Lightning nodes that you open channels with, or they open channels with you. Okay, so your node consists of all the channels, and a channel will connect you, each channel will connect you to another node. The other concept in Lightning is the idea of liquidity. So each channel has some ratio of inbound liquidity and outbound liquidity. And so the reason I'm using the abacus is the easiest way to demonstrate how that works. If you think of the beads as sort of satoshis that you use to open the channel, when you first open the channel, the beads are all on your side because you open the channel. These are your sats, right? You use the sats to open the channel, so they're yours. Okay. Now, as you send sats over a channel, they move to the other end of the channel. So when you first open it up, this is called outbound liquidity. In other words, the sat that you used to open the channel can go out, away from your node. And since there's no sats on the other end, you have no inbound liquidity. So you have all outbound when you first open a channel and no inbound. If somebody opened a channel with you, let's say I opened a channel with you, right? So this is the pulse code node. If I opened a channel with you, my outbound liquidity would be full. So I can send. But you have no outbound liquidity because you didn't open the channel, and so you can't send to me whenever I first open the channel. So whoever opens the channel starts out with 100% outbound liquidity. They can't receive anything on that channel. They can only send. Okay, so let's say I've opened up this top channel here, and I want to send 5 sats over to somewhere. Let's say I'm just sending it to voltage. Just make a simple use case. I've got this channel open with voltage, and I want to send them 5 sats. I can send them 5 sats, right? So I just take the outbound liquidity and I push it over to the other end, and now it is inbound liquidity. So now it's on their side. They have the 5 sats. Okay. So at this point, I now have the ability to receive on my node. I have the ability for somebody to send me 5 sats. So let's say voltage rejected whatever transaction I was trying to do there, and they want to send the sats back to me. So I send them back to me, and now I've got 100% outbound liquidity. I can't receive anymore. I can only send. Okay. Now that might seem weird, like all you're doing is just moving beads back and forth. That's literally how a channel works, and at whatever point it is when you close the channel, this side gets this many sats, this side gets this many sats. Whatever the channel state is when you close it, that finalizes the ratio of who has what. And that might seem, well, doesn't that mean I'd have to open up a channel with anybody I ever wanted to spin Bitcoin over the Lightning Network? No, because there's a concept of routing. So let's say I am connected to Voltage, okay, and Voltages connect to, I don't know, 1,000 customers, whatever, that are also they also have channels, and they have, some are inbound, some are outbound liquidity. Some have sent a lot of Bitcoin, some are full, etc. So there's a range of, on their node, they've got a bunch of channels that some of them have inbound, some of them have outbound liquidity. Okay, and so say I want to send 5 sats to my friend. Okay, and my friend, I don't have a channel open with my friend. He's he's on Wallet of Satoshi or something, right? And he wants to receive some sats. Okay, so I'll say, hey, I want to send sats to my friend. I don't have a channel, but there's the concept of gossip, which is information about all of the other nodes and the channels and the liquidity. It's decentralized. Every node has a copy, essentially, of all that, what they call gossip data. And so I can construct a route that I want to send my 5 sats to my friend. I can figure out what channels that needs to go through, and I can construct a route. Okay, and then I can say, okay, this is my route, and I'm going to send that I need these 5 Satoshis to follow, and I'm going to send them to my friend. And let's say the route starts with 5 Satoshis going to Voltage. So I put my 5 over to Voltage. Okay, Voltage now has 5 more Satoshis than they started with, and now they send 5 to the next step, and then whoever receives that sends 5 to the next step, and whoever receives that sends the 5 to my friend, for example. Now, it's a little more complicated than that because each step will usually have a fee. The default fee is 1 sat, but you can set it at a minimum number of sats and or a percentage of the amount going through. I think 0.01, I believe, is the default percentage, and then the default minimum value is 1 sat. But depending on how many hops, you might incur a little bit of fees, usually not very much. But each time it traverses over a channel to a node, that node will usually charge a fee, and then it traverses to the next node, and that node will usually charge a fee, and so on, right? So in this case, I would have to probably send more than 5 sats so that I could pay the fees along the way, right? So maybe I send 8 sats, and then by the time it gets to the end, there's 5 sats left, right? But that's essentially how Lightning works. The other important point is the route that I construct. The reason that I construct the route rather than telling the next person what my destination is that's a privacy feature. Essentially, it uses what's called onion routing. I'm oversimplifying a little bit, but basically the way it works is I construct the route in such a way that when I send it to the next node, they can only read their part of the route. So they know that it came from me, they know the amount, and they know who it needs to send to next. But they don't know if I was the originator. It may have come from someone before me, and they don't know if where they're sending it to is the destination. There could be multiple hops after that. All they know is where they got it from, how much it is, whatever fee they're charging, and then where they're sending it to on the next step in the route. Okay, so that means that traffic that's going through Lightning is highly private, and a given node only knows about the direct input and the direct output of a given transaction. Okay, so that's a kind of a quick overview of Lightning. You can think of your channel as a whole of having liquidity. So in this state here where I've got all these channels, I've got 100% outbound liquidity and 0% inbound liquidity. But if I, had a state like this, yep, So now I've got 50% inbound liquidity and 50% outbound liquidity on my channel. And it can be much more complex than that. You know, maybe it looks like this. Right? Where I've got varying degrees of inbound and outbound liquidity on the different channels. But if you think from the channel perspective, I've got a certain amount of outbound liquidity, which is the beads that are on this side in this analogy, and a certain amount of inbound liquidity, which are the beads on this side of my channels, right? And so the maximum that I can receive is however many total beads there are in one transaction. It would come over multiple routes and through all my channels and become outbound liquidity again. Okay, so that's basically how Lightning works. We'll start with something. Something very simple. We'll just have one channel. I'm going to open the channel up with my node once we get this set up, and then sort of as you play around with it, you can start opening more channels. You can start finding good places to have channels set up where you get to your routes easily. You don't have trouble finding routes to your destination, and so on. There are big ones like I've got a few examples of them here, like voltage and async and bolts. These are well connected. Wallet of Satoshi, I think I have on here. Yeah, Wallet of Satoshi is another one that's really well connected. So you don't need a lot of channels. Even one channel to a really well connected node will be sufficient for a lot of people. So just find a good connection. There's a setup fee, like there's a minimum amount of liquidity you have to have on a channel with a given node. Like Wallet of Satoshi, I think is like 10 million Satoshis, which is pretty high. Bolts, I think, is 1 million, which is also pretty high. My node, just so you can play around, I've set it at 10,000 Satoshis minimum. So, which at current prices, that's like $7 somewhere, a little less than $7. So you can set up a connection with my node, and I'll show you how to do that when we get to that step. So you can play around with there, and then when you're ready to actually connect to another node after you've experimented and sort of learn how it works, then you can open to a more well-connected node. You'll have to have more Satoshis to open up that channel. One note about that as well. When you open up the channel, you have to have that amount of Satoshis to open the channel, but you can send most of them. I think there's a minimum you have to keep for emergency closures. But most of the channel you can send. So as soon as you open up, say you open up with voltage and you spent 1 million Satoshis, for example, and you want to put that 1 million Satoshis into cold storage, you don't want to leave it on your channel. You just immediately send it to your own wallet, or you can send it to bolts and convert it to Bitcoin, for example, and go straight to your cold storage. And so you have to have that amount of Bitcoin to open the channel, but you don't have to keep that amount of Bitcoin in your channels. And I would recommend not keeping too much Bitcoin in your channel. First of all, because it's a hot wallet, don't put more in your channels than you're willing to lose. If someone were to hack your machine and you're running out of Windows, it's more likely to be hacked than if you had a dedicated server. And also, I haven't showed you how to actually back up your channel, back up your node in case your computer crashes or something, you need to restore it. I'm going to actually show you how to do that in another video. So initially, I would just start with a small amount, maybe connect to my node, and play around with, or find some other small nodes. Maybe you got some friends you can open up nodes with, or open up channels with, and play around with it. But I wouldn't lock too much up in there initially until you're comfortable with it, and you've got a plan for backing up your node. Okay, so let's get into the actual setup process. First of all, you're going to need Bitcoin Knots or Bitcoin Core, and you want it set up as a full node, and you need to be fully synced. Okay. Now I've got the process outlined, so I'm going to go ahead and bring it up. So if you want, you can have this up while you're working and follow along with it. It makes it real easy. Or you can follow along with the video if you want to do it that way, or you can have both open. So let me go to search for GitHub, Paul's code. Okay, and it's this one that says Paul's code, Paul Lamb on GitHub. Click on that. Then we're going to click on repositories. And it's this repository. It might not be at the top when you get here. If it's not, just scroll down through the repositories. The one you want is Windows WSL Lightning. Okay, and WSL is Windows Subsystem for Linux. That's what we're going to run the Lightning node on, because it's not designed to run on Windows, it's designed to run on Linux. So we're going to use the Windows Subsystem for Linux to run it. So that's what WSL stands for. So Windows WSL Lightning is the repository. So we'll click on that. Okay, and then on the README, just whenever you open the repository, it outlines the process. Okay, so we'll start with step one. Step one says we need to enable virtualization. There's two places you have to enable it. One is in the BIOS and one is in a Windows setting. We have to do the BIOS one first. So to do that, we'll reboot the computer and we'll hit whatever hotkey to get into the BIOS. That's going to depend on your computer. So if you don't know that, you probably need to consult the documentation. Or you can, if you want to try to work through it, you can't find the instructions, you can probably interact with ChatGPT to help you figure out ways to actually get into the BIOS. Once you're in the BIOS, then I'll show you what you do. So we're going to go ahead and do that. We're going to close this down. We'll close Bitcoin Knots so that we can reboot. Now wait for it to fully shut down. Okay, so now we're going to reboot and we're going to look for whatever hotkey that we need to press to get into the BIOS when we're booting up. Okay, it says press enter to interrupt normal startup. Okay, it says F1 to enter BIOS. Okay, now when you get into BIOS, it will most likely look different than this because every computer tends to have different BIOS. There's some common ones. This isn't one of the common ones. This is a Lenovo BIOS utility. If you have a Lenovo, then it'll probably look like this. Otherwise, it's going to look different. But we want to look through here. Usually, you're going to find it in either advanced or CPU settings, depending on the BIOS. You're looking for something that has the word virtual in it. So it could be just virtualization. It could be Intel virtual technology. It could be AMT virtualization. Something that has the word virtual in it. That's what we were looking for, and we want to make sure it's enabled. Okay, in this one we've got advanced CPU setup. It's probably going to be in there. Yeah, we've got Intel virtualization technology on this one, and it's already enabled. If it wasn't enabled, I'd look at whatever the command tells you what commands to press to actually navigate, usually at the bottom, or maybe it'll be on the side depending on your BIOS. But you'll press whatever commands to actually edit that row if it's not enabled and make sure it's enabled. Then we're going to press whatever commands to save and reboot. So in this one, it's F10 to save and exit. And I'm going to confirm yes. Okay, so now that virtualization is enabled, now we need to tell Windows to use virtualization so that we can use WSL, which is where we're going to be putting our Lightning node. Okay, well, this is written in the instructions, but I forgot to mention it. You need to make sure that Bitcoin Core or Bitcoin Knots is installed in the default location. To check that, if you're not sure where you installed it, go to this PC, go to C, go to Program Files, and go to Bitcoin. If you can get to this folder, then you've installed it in the default location. You're good. If this folder doesn't exist, if it's a different path, stop. Don't continue with these instructions because these are assuming that it's there. If it's somewhere else, post in the comments. I can help you out, and maybe we'll do another video on how to install this if you're in if you've got Bitcoin Core or Bitcoin Knots installed in a different location. But it has to be in the default location on Windows, which is C, Program Files, Bitcoin. All right, let me start my Bitcoin node back up. and I'm going to go to the instructions again. And I'll go ahead and save this in a favorite so I can get back here because we're going to reboot a couple of times in the process. Okay, so this is what I was talking about earlier. Make sure you read the important notes. Bitcoin NOTs or Bitcoin Core must be installed on Windows. It must be configured as a full unpruned node, and it must have completed the initial Bitcoin or initial blockchain download sync process. Also, the scripts assume that the default location was used, so C program Bitcoin. If that's not where you install it, stop, do not proceed. Okay, so we did parts of step 1. We rebooted the computer and we enabled virtualization in the BIOS. Now we're going to go to the taskbar and we're going to search for turn Windows features on or off. There it is. We'll go ahead and click that. And then what we're looking for is virtual machine platform. We want to enable that. Okay, it's already enabled. Just need to make sure the checkbox is checked by it. If it's not checked, you just check it, and then you hit OK. Okay, so we completed step 1. Now virtualization is enabled, and so that means we can use WSL to install our Lightning node. So for step 2 is we need to actually install WSL. It's going to create an app called Ubuntu. So when I'm talking about Ubuntu or if I'm talking about WSL, I'm talking about the same thing. It's the Linux environment that we're going to be installing our Lightning node into. So we need to search for Windows PowerShell. And the instructions mention this, but you want to right-click it. You don't just click on it, you want to right-click it and run as administrator. And it'll say, do you want to make changes? Yes. Okay, now it says type in this command. One nice thing about this instructions is I've got this copy icon over on the right, so you can click that to copy it to the clipboard. And then in WSL or in PowerShell, you can right-click to paste. Okay, so I just right-click it, paste it. So it's WSL --install is the command, so I'm going to run that. And this will take a few minutes, but it's installing Ubuntu. And while that runs, let's read ahead. The next thing it's going to ask for is to create a username and password. This can be the same as your Windows username and password, or it can be different, doesn't matter. You just have to remember what it is. So if they're different, you have to have one set of credentials to get into Windows and a different set of credentials to get into WSL or Ubuntu. Okay, so it says enter a new Unix username. So I'm just going to call it Satoshi. It says enter a new password. I'll use the Bitcoin launch date. Okay, it's installed successfully. Okay, now it says close PowerShell and reboot. So since I opened up Bitcoin NOTs, I need to close it and let it shut down completely. Okay, we're restarting. Okay, so let's go load our instructions again. Okay, step 3, we've completed step 2, which was installing WSL, or it's called Ubuntu. So we've installed that. So now step 3 is configuring the firewall. This is the most complex step, but it's not too bad. It's all graphical interface, so just follow along with what I'm doing here. We're going to first search for and launch the Windows Defender firewall. Now the reason that we're needing to do this is because we need WSL Ubuntu to be able to talk to our Bitcoin node. And the firewall is blocking that by default. So we need to open up that port that it needs to talk to from WSL to be able to talk to the Bitcoin node, so that we can process payments, know where the block height is, and so on, right? Open channels, closed channels, etc. Needs to be able to talk to your node to do that. All right, so first thing is we're going to hit Advanced Settings. Then we're going to click Inbound Rules. And we're going to create a new rule. It's over here on the right, New Rule. And it says we need to select Port and then Next. So we're creating a new rule based on a port. This is going to be the port that the Lightning node talks to the Bitcoin node. It's TCP, so leave that as TCP. And we're going to say select specific local ports is what it's called. And we've got that in the instructions as 8332. That's what we're going to enter in there. So we're just going to paste that in there. That's the port. That's the Bitcoin RPC port, 8332. So we've got TCP selected, we've got specific local port selected, and we've put in 8332. And then we're going to click Next. Then we need to make sure Allow Connection is selected. And then we're going to click Next. Now here, you got a couple of decisions. We need private to be selected for sure. If you run your Bitcoin node in a corporate environment, maybe you bring it to work or something, you got a corporate network, then you also want to select domain, otherwise you leave it unchecked. And in most cases you're going to leave public unchecked, but if you ever run your node in your public Wi-Fi, like at a coffee place or whatever, then leave that one checked. In most cases you're only going to need the private to be checked. So depending on your scenario, leave private and whatever other ones you need checked, but make sure private at least is checked. Then we're going to click Next. Now we need to give a name and a description. I've got a name and description in the instructions that you can use, but basically I'm calling it WSL Bitcoin RPC. RPC is the protocol that the Lightning node talks to Bitcoin, your Bitcoin node over. And then WSL is where it's running, and that's their Ubuntu. So I'm just going to name it that. You can name it whatever. This doesn't matter. This is just for your purposes, so you can find it easily. And describe what it's doing to yourself if you ever forget why you added it. So I've got this description in the instructions. It says enable services running in WSL, such as Lightning, to communicate with your Bitcoin node using RPC. So that's the description I put in there. It's kind of descriptive, saying what it's doing. Then we're going to hit finish. Now there's one more property we want to update on here, just to make it a little more secure, so that nobody else can reach in and communicate with your Bitcoin node. You want only WSL to be able to communicate with your Bitcoin node. You don't want anybody else on the network, or if you had public, that'd be anybody on the network. Like if you're at the coffee shop, you don't want them connecting to your Bitcoin node. So we're going to find the new rule that we just added, was called WSL Bitcoin RPC, or whatever you named it, and we're going to right click on that, and we're going to go to Properties. And the property that we want to update is under Scope. So we're going to click Scope tab, and then right now it's set for any IP address. We're going to change those to these IP addresses. So both of the radio buttons for local and remote say these IP addresses. And then you're going to copy this IP address range from the instructions, and you're going to add it to both. Did I close that? It's too closed. Oh no, here it is. Yeah, I don't have enough room. I usually have more screens whenever I'm doing this kind of stuff, but right now we just got this one screen. So Yeah, here it is. So I'm going to hit add to add that range from the instructions. And the range is 172.16.0.0/12. That where that came from, I just Googled that. That's the range that WSL IPs might be in. That's all that is. So I just copy pasted that from some instructions. I verified on multiple sources that that's the right range to use, so that should be correct here. And I won't let anybody else in that's outside of that range. I'm going to do the same on the other. So we've got our local IP addresses and our remote IP address. We're going to add the restriction to both of those. So it doesn't matter where the connection is coming from. If it's not on that range of IPs, it's not allowed in. Okay, then we're going to hit apply and then OK. Okay, and then it says we can do close Windows Defender Firewall. So that was the most complex step there. The rest is going to go a lot easier. But it's not too terrible. Okay, so now we need to launch. So we're on step 4, configuring the Bitcoin node RPC settings. So out of the box, Bitcoin Core or Bitcoin NOTs, they're not going to have RPC settings configured, so there's no way to actually control your node without that enabled. So we're going to set those up so that the Lightning can actually communicate with your node. So we need to launch Bitcoin NOTs first, or Bitcoin Core if you're not using Bitcoin NOTs. Okay, it's loaded up. We're going to go to settings and choose options. Then we're going to enable RPC server. There's a checkbox right over here. I'm going to enable it. But we need to configure it also. We don't just need to enable, we need to give it the properties that it needs. So for that, that's in the instructions. We're going to copy those. Just click on the copy icon and copy those into the clipboard. And we're going to do open configuration file. And then we're going to hit continue. Okay, so you may have some settings already in here. If you do, make sure that, just look through the settings that you're about to put in here. We'll just paste them in here. Look through those. If you got those set somewhere, like the same setting somewhere else, just delete the duplicate and make sure the value is the ones that we have here. The only things you need to change are your RPC user. I just put some user in there. You need to put an actual credentials in here that you remember, and don't share those with anyone, because if somebody has those, they can control your node over RPC. So we're gonna put some credentials in here. I'm gonna call the username Satoshi. Let's see, password Nakamoto. Let's just say, I'm just making up some stuff here. So I got Satoshi as the username, Nakamoto as the password, and the rest will stay the same. So we're going to hit save, and then we're going to hit OK. Okay, so we're going to go ahead and leave that running for now. And we're going to go to to WSL. So you're going to go to your taskbar and you're going to search for Ubuntu. Ubuntu. Okay, there it is. We're going to go ahead and run that. Now, one thing I want to note is when this comes up, if you don't see the cursor flashing, it doesn't have focus, and if you type stuff, it's not going to go do anything. So you want to click on the window again, and if the cursor's flashing, then you're in there and you can type stuff. So just take note of that. If you're trying to type or paste something that's not working, make sure the cursor's blinking. That tells you that you're in the window. Okay, my cord's a little messed up, so the screen might flicker off every so often. Okay, so we're in there. And we need to enter the following commands. So we're going to just copy those commands. Now, one thing I want to show, I'm just going to do this. I'm not going to go through them. I'm going to go through these scripts at the end. These are the scripts that make the steps much easier. I'll go through them at the end. I kind of want to just show you, rather than taking too much time out of the process to explain. I'm just going to use them, and then I'll come back and show you. But you can see the two scripts that we're using in this repository. One's called Lightning Setup. That's the one we're about to run. And one's called Application Setup. So at the end, whenever I get through, at the end, I'll go through what's inside of those. These are open source. I would recommend, don't trust me, get one. If you know how to read scripts, go through and make sure they're nothing nefarious in there. If you don't, maybe you got a friend who's a computer geek, have him take a look over it. Just get somebody else to look at it before you trust somebody to just run a script that somebody's written. I mean, I can tell you that I'm honest, but you don't know that, so verify, don't trust. But if you trust me, and you verified that I'm trustworthy, then these are the scripts that we're going to be running here. And so we are on step 5, and we're getting ready to run that Lightning Setup script. As soon as I paste that in, it's going to start running. I've set it up where when I copy and paste it, immediately runs it. Okay, so I'm going to go ahead and paste that in there, and it's going to start running. To paste, like I said, you right-click. So when the cursor is flashing, if the cursor is not flashing, click on the window, and the cursor should be flashing. And then just right-click in the window will paste whatever we've copied. So paste. All right, and now it's running. Okay, so it says, let's collect some parameters to set up your Lightning node. First, enter a name for your node. I'll call it foobar 22. Doesn't matter. Just give us some name, meaningful name for your node. If you're going to publish this node on like 1ML, for example, you want to give a name that people can recognize you by. Otherwise, it doesn't really matter what your node name is, whatever you want to call it. You just have to give it some name. So I'm calling mine foobar 22. And it says you need to enter a color hex code for your node. I have it defaulting to FAA500, which is the Bitcoin orange. But you can change if you have another color you want to use. This is if you're doing any kind of node explorer or anything like that, your node will show up a certain color usually. This is where that color comes from, is in this configuration. So I'm just going to leave it orange. If you want to leave it orange, just press enter. If any time I say default and then I have some value, you can just press enter and it'll use the default value. So in this one, I'm just going to press enter, and then I'll be using the Bitcoin orange is what that means. If I press enter, I'm using the default color. Okay, then it says you enter your Bitcoin RPC username. That one I called Satoshi. Let me get the exact spelling though, because I want to make sure that it's the same in my RPC settings as it is in my configuration. So I'm going to go Settings, Options, Open Configuration File, Continue. Yep, Satoshi, all small letters. So I want to make sure that I'm using that same thing. Okay, enter your Bitcoin node's RPC password. Same kind of thing. I'm just going to copy it. Now you might, on the password, you might want to type that rather than copy paste. And the reason is you can't tell if it's pasted or not. I'm comfortable with pasting it because I've used this enough. But if you're going to try to paste, if you're not typing it, you're going to try to paste it, you make sure you click on the window, make sure the cursor is flashing, and make sure you right click only once. If you click twice, it's going to paste it twice. So click on the window, make sure the window title, click on the window title, make sure the cursor is flashing, and then right click inside the window to paste. Okay, then we'll press enter. Okay, the last thing it asks for is the Bitcoin RPC port. We use the default port, so we're just going to press enter. That's 8332. If you put something else in there, you'll have to change it, but we can use the default value, so I'm just going to hit enter. It says, okay, ready to set things up. This will take a few minutes. Now it's going to ask for my WSL password. This is the one we set up whenever we when we did WSL install, an earlier process. This might be your Windows credentials if you use them, or if you created new credentials, this is those it's that password that we're talking about. So whenever I did the Bitcoin launch date, so I'm just going to type that in. Okay, and if it's wrong, I'll say that's the wrong password. You have to try again. So make sure you get the right password. And now we just sit back and let it do its thing. What it's doing at this point is it's updating packages to make sure they're all current. It's installing some packages that we need. There's a couple of rounds of that. There's packages and there's also Python packages. It's doing both of those. It's installing and configuring Tor so that your communication's private. It's all going over Tor. It's creating an authentication header, what they call a rune. That's not the same as the spam runes on that the wizard folks are doing. This is a different meaning of that term. That it just means essentially an access token. So it's generating one of those and saving it in the config. It's making sure the permissions are set where nobody except you can read them. And then it's configuring its connection to the Bitcoin node through RPC with the credentials that we entered. So basically that takes a little while to get through all of that. While that's running, let's go ahead and look at the instructions to see what we're going to be doing next. Okay, it says wait for the script to finish executing and then enter these lines. So we're going to, once it's done, we're going to enter these two lines. This is going to actually shut down WSL whenever we run these. So we'll wait for it to finish here. It takes a little while to get through all this. It's quite a bit of setup that it needs to get through to get this is essentially installing the Lightning daemon. Okay, it's completed. So next we're going to run the last two commands here to reboot the WSL. So again, we make sure the cursor is blinking by clicking on the window title, and then we right-click inside the window to paste. Okay, so my weather radio went off and did a test in the middle of this. Basically what I was saying is we've completed this last set of commands. The remove the setup script. So that one basically says we don't want to accidentally run it again, and then reboot, which closes down the WSL window. If you forget and skip this step, that won't hurt anything because you're going to reboot the whole computer anyway, which will reboot WSL in the process. But the idea is to get rid of that installation script so you don't actually try run it again later. Okay, so now it says close down Bitcoin Knots or Bitcoin Core, wait for it to completely shut down, and then reboot the computer. Okay, so let's wait for Bitcoin Knots to shut down. Okay, so now we're going to reboot the computer. Okay, so let's go back to our instructions. Okay, so we've set up Lightning D and WSL. That's step 5, that's the one we finished. Lightning D is the Lightning daemon. And then the next step is setting up the core Lightning application. We're going to, at the top of this step, you can see where we're actually going to test the Lightning daemon and make sure there aren't any errors before we proceed with installing the core Lightning application. So the first thing we need to actually run is Bitcoin Knots or Bitcoin Core and make sure that it's connected to a couple of peers before we start our tests. Okay, you could probably start this as long as it has at least one arm colored in. I usually wait for 2 just in case the first one drops when I'm trying to do a test. So I try to make sure I have at least 2 connections. So I'll give it a little bit of time to get another peer connected. Okay, now we got 2 peers. I'm comfortable with proceeding with the test. So we're going to search for Ubuntu and launch it. Okay, here's an example where the cursor is not blinking, so I'm not actually inside this window. If I click on the window title bar, now you can see that the cursor starts blinking, and so that's how I know that I'm in there to actually run some commands. Okay, so it says the first thing I want to do is actually launch the Lightning daemon and see if it produces any errors. So I'll just go ahead and copy the command. It's just lightning D. I could type it also. Lightning D, and then I press enter to launch it. And we're looking to see if it produces any errors. Takes a few seconds to launch. Okay, it launched and there were no errors printed. Okay, so that's a good sign. If you get errors here, just don't proceed. Post in the chat and we can try and figure out what went wrong. Or I can show you how to clear everything and start from the beginning, maybe missed a step. But if we get here and there's no errors, then we proceed to the next test, which is we're going to look at the logs that were created when it started up, and we're going to see if there's any errors or missing modules. Okay, so we're looking for anything that says error, and we're looking for anything that says missing module. Okay, and for that we grab the command out of the instructions here. It's cat.lightning/log is the command. cat.lightning/log. Okay, so we're looking to this log, and if we see anything in this column that says error, we want to stop. Okay, nothing in here says error. Okay, next we're going to look at the descriptions in this column. We're going to see if anything talks about modules missing or plugins being disabled. Yeah, there's nothing in there. So what usually will happen is if there's been an upgrade, for example, you're doing a newer version of the Lightning daemon, they may have new required Python packages to be installed. And if they're not, it'll say missing module, and it'll say some name, and it'll say disabling plugin so-and-so, like the CLN API, for example. Missing PQ, disabling, missing module PQ, disabling the CLN REST API plugin, for example. That's probably not an actual real scenario, but the point is there'll be some module that's missing, which results in some plugin being disabled. So if you see any of that, stop, don't proceed. Or if you see any errors, anything in the column that says error, stop, don't proceed. In this case, we're good. So we're going to continue on to the next step. So this, again, it says right here, if there's any errors, such as module missing, stop here and do not proceed. Okay, we're good, so we're going to go ahead and proceed. It says if there's no errors in the logs, enter the following commands. So this is going to set up the core Lightning application. This is the UI that you're going to be using to interact with the daemon. So we're going to click that to copy it to the clipboard. Going to make sure the cursor is blinking. Right click inside the window to paste, and now it's running. Okay, I need to enter my password for Satoshi. This is my WSL password. This is the Bitcoin launch day is what I use for my password. Whatever your password you used, enter that here. Okay, and now it's going to install the core Lightning application. This one will also take several minutes, so be patient and just let it run, and eventually will complete. You'll see some warnings about deprecated packages. Hopefully the devs will update the package versions to get rid of those, but that's expected. In this version of the core Lightning application, they've got some deprecated packages they're using. There's actually some identified vulnerabilities that'll show up at the end, but that's not my code. That's the core application code itself. So if you're using the core application, then those are in the current version, and so hopefully they'll get fixed in the future. But there's not much I can do about that because those are built into the package itself. So and some of these packages take a long time to download, so it'll look like it's hanging. Just be patient. Just wait until you get to the end. It'll say that it's done. So don't be like trying to restart it or thinking that it's froze or anything. It's most likely just taking a long time to install. Some of these packages take a long time. So. Okay, this part you can see that it identified 25 vulnerabilities, 12 high. It says you can fix some automatically with npm audit fix, which I run in the script. It'll automatically do that. But some of them would require breaking changes. Those are the ones I can't fix automatically, so there will be some remaining at the end. But it's fixing the ones that it can fix right now. Okay, so it brought us down to 14 vulnerabilities, 6 high. And you can see now at the end it says CLN application setup is complete. Please reboot and ensure Bitcoin Core is running before proceeding. Okay. So in our instructions it says wait for the script to finish executing, which we did, and then we entered these commands here to basically delete the installation script so you don't accidentally run it again, and reboot WSL, which shuts it down so you can reboot the whole system. So we're going to go ahead and copy those. Again, if you forget this last step and you just reboot, that's fine. You don't necessarily need to run this, but if you're following the instructions closely, this step deletes the installation script and shuts down WSL. Okay, so WSL is shut down. We need to reboot the computer, so we're going to go ahead and close down Bitcoin Knots. And wait for it to shut down completely before we restart. Okay, so at this point we've got our Lightning node installed and it's ready to run. I'll show you the process for starting it up whenever you want to run it. It's also in the instructions. If you forget, just go to the last step, step 7. It shows how to start up the Lightning node. It also tells you the commands to run to shut down and reboot your computer whenever you're done using it. One thing to note on a Lightning node, especially if you're doing a lot of routing, it needs to be online essentially all the time. When you're offline, no information is traveling between channels. Plus, the way that Lightning is decentralized is with the gossip data that everybody has a copy of, essentially, of gossip data to create their own routes to wherever they're trying to send a payment. If you're offline for a long time, it's going to take a while to catch up all the gossip information. It's also true when we first run it. We first run our node and create a channel. Our gossip information is empty. Essentially, it's going to take a few hours to be able to collect enough information to actually send some payments. So I'm not going to actually send a Lightning payment in this video. I'm just going to show you how to get that channel initiated, get some Bitcoin into your node so that you're ready to start opening up channels. And we'll stop the video there, and I'll do a future video to go over some of the important maintenance things, like now that you've got it open, how do you actually send and receive payments? How do you close a channel? What's the process of that look like? How do you open up inbound liquidity? How do you back up your Lightning node in case something happens to your computer? And then we'll also talk about the importance of eventually when you've been in the space for a long enough time and you're ready to go to the next step, eventually setting up your own node and not using Windows, because Windows has a lot more security vulnerabilities than a Start 9, for example. Anyway, so let's go ahead and launch our node. I'm going to bring up the instructions so I can show you where that is. That shows you how to launch everything. Okay, so the last step says step 7, enjoy. It says launch Bitcoin Knots or Bitcoin Core. Wait for it to connect to some peers, just like we did. I usually wait for it to have 2 legs on the 2 peers connected before I start running my Lightning node. Okay, so we'll go ahead and do that. Okay, so we got 2 peers connected. So we're gonna go ahead and run WSL. Search for Ubuntu and launch it. Okay, the first command we need to run is the Lightning daemon, and that is Lightning D. That'll take a few seconds to run. It gets the daemon running and ready for the application to connect to it. And we're going to be using the application to work with our node. Okay, so the Lightning daemon's running. Then we need to run the application. It's cln-application. Now I could have run this in the background, but I on purpose did not. And the reason is it's very useful to have this window, this WSL, this Ubuntu window open, because your logs are going to show up here. So if you have a problem, maybe it says a payment couldn't be made. If you come to this window, you're going to see a lot of information potentially about what error happened. So this is really helpful. If you're using Start OS, it's very similar. They've got the logs page where you can see what's going on with your Lightning node. This gives you the equivalent here in Windows is with this WSL window. We can go in here and check our logs if we need to. So to launch the application, we just need to grab this URL. It's the one that ends in 8080. So it starts with http:// it has an IP address :8080. So you want to grab that. Don't grab the double quote, just grab the URL. Okay. And then we're going to right click, that puts it into the clipboard. Okay, so now it's copied. And we're just going to go into our browser and we're going to paste and go to that URL that we copied from the log. Okay, so now it's going to ask us to create a new password for our node. I'll just use the Bitcoin launch date again. And set password. Okay, so now this is the interface that we use to actually interact with our Lightning node. Before you can do anything, you need to have some Bitcoin in here. So what we're going to do is we're going to actually deposit some Bitcoin into our channel, or into our node, and then we can use that to open up channels. I'm going to put a small amount in here because I don't want to spend a lot of money for this demo, so I'm just going to put, let's say 50,000 sats, let's say we'll put into here. So let's do deposit. So over on the Bitcoin wallet, we're going to click deposit. And that's going to give us a Bitcoin address that we need to send some Bitcoin to. This is a base layer address. So you're going to get a base layer transaction fee whenever you send Bitcoin here. Okay, so I'm just going to send. I've got Breeze set up on my phone, so I'm going to send it from here. If it'll load up. Yeah, so going to send 50,000 sats. Oh, no, it's in BTC. 50,000 divided by 100 million. It's 0.0005. Okay. 0.0005. Bitcoin address, we're going to scan the QR code. And next. We'll send it on priority, I guess. Confirm. Okay, so now we just need to wait for the transaction to happen on the base layer, and then it'll show up in our balance here once that completes. If you want to see sort of how long it's going to be or when it happens, we can go to mempool. .space. Okay, it looks like the transaction was broadcasted to the mempool, so I'm going to go ahead and copy that so we can bring it up in mempool.space and watch to see when it's going to be confirmed. Okay, so I put the transaction ID on a text file on this USB. I'll go ahead and load it up. Okay, has one confirmation already, so that's good. Let's go and refresh our page here and see if it comes up. Okay, so we got 50,000 sats in our Lightning node. In the next video, I'll go into more actually using the tool. and in the next video we'll start creating channels. One last thing before I go, I want to show those scripts. You can skip over this if you want to come back later with a friend that's a computer savvy or whatever to go over this part of the video. This part I'm going to just show what these scripts are doing, and then you can have, if you understand scripts, you can confirm that what I'm saying is actually what they're doing, or you can get somebody that's computer savvy to look over with you and make sure that what I'm saying is actually what these are doing. So the two scripts that we ran, one was to set up the lightning daemon. That one's called lightning setup. That was the first one that we ran. So let's open that one up. So what this does, make sure you're not running it as root. If it says don't run this as root, and he's running as a normal user. Then make sure that you've only run the script once. So if we've got the config file for the lightning daemon already, then we know we've already run the script, and it's not going to let you run it again, because if you run it twice, it's going to step on itself and create problems. So it only lets you run it once. Then it gets the IP address of the WSL Ubuntu, the virtual machine. It's grabbing the IP address of it using hostname. Then it's getting the IP address of the Windows computer. That's where your Bitcoin node's running. It needs that IP address to talk to Bitcoin. It's using name server. It's looking for name server in Etsy Resolve for that. Then it's getting your Ubuntu version. Potentially there could be multiple different versions of Ubuntu that might run in WSL, so it's grabbing whatever version of Ubuntu you're running, because it needs that layer to decide what package to download. Then it just says, hey, let's collect some parameters. It asks you to enter some parameters. Enter the name of your node, enter the color. If you don't enter a color, then it uses Bitcoin Orange. It asks for the RPC user and password and the port. If you don't enter the port, it uses the default, which is 8332. And then it says, okay, things are ready to set up. It's going to take a few minutes. It sleeps for 2 seconds while you read that message before it begins. Then it starts doing its thing. So it creates the .lightning folder. That's where all the configs for the lightning daemon go. It does an update and upgrade. What that does is make sure all the packages in Ubuntu are up to date. There's no out-of-date stuff that might have security vulnerabilities or anything like that. It's going to make sure everything's up to date. Then it's going to install some packages that we need. We need libpqdev, nettools, npm, Python 3 full, Tor, and JQ. These are things that are used by either the lightning daemon or the core lightning application. Make sure that the user is in the Debian Tor group so that the user can use Tor. It then sets Tor settings for the SOCKS port. It only accepts traffic from WSL, the local machine 127.0.0.1, and rejects all others. This is sort of making sure that nobody's getting into your Tor router. It's just you. You're the only one that can use it. That's what that does. That locks it down. Run as daemon. That means run in the background. We don't want to have a log like we did for the core lightning application. We just want to run in the background. So that's what that does. It tells us where our data directory is for all our files for Tor. And it creates a hidden service for lightning. This is needed in order to create the key. So we have a key and a rune that I talked about earlier. The key is created by Tor. So it's going to put it in varlib Tor lightning. It tells what version it is. It tells what port it's going to be on. And it maps that to the local port. So the Tor port maps to localhost 127.0.0.1, the same port number. So we've got our onion port maps to our local port. Then we restart Tor, and we wait for it to create that host name because we need that for our configuration. So if we don't have it right away, we sleep for 2 seconds, check again, sleep for 2 seconds until it appears. Once Tor has created that file, we go ahead and grab it, and that goes got it. So it's getting it via varlib Tor lightning hostname. Then it creates a virtual environment. This is needed for current versions and installations of Python. So it creates a virtual environment under the home directory called venv, and it instantiates it. Then it updates the path to use the Python and pip commands are going to go to that virtual environment. Instead of using the system Python and pip, it's using the virtual environment Python and pip. That makes sure that when we're installing packages, it's installing it just in that virtual environment. It's not potentially stomping on the system Python packages. It's isolated just for this user, this particular virtual environment for this user. Then we install a few Python packages that we need using pip3. So we've got cryptography, Flask, various Flask modules, G-Event, Unicorn, JSON5, Highline Client, and WebSockets. These are all requirements for the core Lightning application or the Lightning daemon or its plugins. So various different things need different Python packages. So we're installing all the Python packages we need here on this row. Then we're getting the actual from GitHub. It's going and grabbing the current release for the Lightning daemon. It's unzipping that and moving it to a particular folder. We're calling it C Lightning. And then it's adding the bin folder for that to the path so that we can run the commands for the Lightning daemon. Like the Lightning CLI like we ran earlier when we were making the connections, for example. Then we're going to create a config. I want to make sure it's locked down where only you can read that config file. Nobody else, like for some reason somebody gets nobody access or no group access, whatever, you know, this is kind of inside technical Linux stuff. But if somehow somebody gets on there and they're not you, they're not going to be able to read your config. So that keeps your like credentials and stuff like that safe. So you'll see that a lot where I just touch the file to create it empty, make sure it's locked down before I start putting things into the file. That's what I did with this config here. So now we've got this config file created and locked down. Now we put in the values in there. And the reason I did that is because we've got our Bitcoin RPC user and password. And the RPC password is obviously sensitive information. So I locked down the file before I wrote that into the file. Next, we are going to create the log file for the logs to go into, and those potentially are sensitive as well, so I've locked that down. I created the log file and locked down the permissions so only you can read it. I did that for what's called the commando config that has your rune. That's another sensitive piece of information, so I created that one, locked it down. And then the core Lightning application is a script that we're going to run, and that has sensitive information, so I make that so only you can see it and execute it. So that's why that one's 700, the others are 600 because they're not executable. So the log and the config files are all going to mode 600, which means I can read and write them, but nobody else can see them. And the core Lightning application script that's going to launch core Lightning application later in the next step, that is set where I can read, write, and execute, but nobody else can see it. Okay, so then it's going to actually create the bash script for CLN application. This is what runs when I type CLN application. Remember, we're launching the UI that we're going to go into. So this is the script that actually will launch that application. We haven't installed the application yet. We're just creating the script that's going to launch it after we install it. So this just puts all the required configurations in there, and again, it's got like sensitive information. It's got the commando config location. It's got like the Windows IP address that it is. So this information that's potentially sensitive, so that's why I locked it down. And then it just runs the CLN application via npm run start. That's the command that launches the CLN application. Okay, so it creates that script. We can't run that yet because we haven't installed CLN application at this point. It's just sitting there ready to run, and we're going to run it in the next step after we install CLN application. Lastly, it adds the repository for node source. That's Node.js that's used by a CLN application. I have to add it because we specifically need Node version 20, and the Node version 20 is not on WSL, at least at this time. It might in the future, but it has Node 18, and Node 18 is not compatible with CLN application. So, so we're setting the repositories for node sources, the source code for Node.js, and we're pulling in the Node 20 distribution right here. So we've got node_20.x right here. So that makes sure that when we install Node, that we're installing version 20. Then we update our package list and we install Node.js. Okay, so that's going to install Node 20 right here. And then we're going to auto remove any unused packages. So at this point, we've sort of created a mess with the package. We've installed a bunch of stuff's been uninstalled. There's dependencies that are no longer used. So there's a bunch of packages left over that are installed but not needed. And so that's what this line does. It does the auto remove. It auto removes all the unused packages. And it says setup complete, please reboot, etc. Right? So that's the end of that script. Okay. The next script, so after you reboot, and then remember that at this point we went in and we ran the Lightning daemon, made sure there was no errors. We looked at the logs, make sure there was no errors in the logs. And then we were ready to install, if everything looked good, we were ready to install the core Lightning application, CLN application. That one, that's called application setup. That's the script we ran for that. Okay, so in here, it's going to make sure, again, you're not running as root. It needs to run as user. If it does, it says, hey, don't run as root, you need to run as a normal user. Then it checks if we've run that other script. If we try to run this one first, it's not going to work. It needs the other one. It needs the Lightning daemon to be installed. So you have to run that other script first before you run this one. So it checks, hey, did we create the commando config? If not, oh, we haven't run that other script yet. So let's just stop here and say, hey, you need to run that other script. Okay. Then we're going to check if we've run this script. So this script creates something called config.json. So we say, hey, does config.json exist? Yes, that means we already ran this script, and we stop and say, hey, you can't run this more than once. You just need to run it once. So it stops if that file exists. Then it makes sure that the Lightning daemon is actually running, because we need the Lightning daemon to be running for this script to work. So it checks the processes and says, hey, is Lightning D running in the processes? If not, it says, hey, you need to run Lightning D first before you run the script, and it stops. Okay. Okay, so if everything's good, now it goes to the home folder, and now it gets the Lightning public key using Lightning CLI get info. It actually needs to parse that out using grep. So it uses grep to parse out the Lightning public key from Lightning CLI get info. This is why we need the Lightning daemon to be running, because Lightning CLI doesn't work if the Lightning daemon's not running. But we're using that to get a public key for our node. Then we need to create a rune. And we're creating a completely unrestricted rune. We want the Lightning application to have full access to the Lightning daemon, so we're not getting in any restrictions. So this is a very sensitive piece of information, this rune. If somebody has this, they can drain your accounts, right? So that's why we did all that steps of making sure everything's locked down before we do anything with this. So what we're doing here is now we're actually generating it. Saying, okay, Lightning CLI commando rune, and we've not given any restrictions. And then we're using JQ, that's the package we installed earlier, to parse out the property called rune. Okay, so whenever you do commando rune, it generates a JSON file, and one of the properties in there is called rune, and that has the actual string that we're trying to get. So we're going to parse that out, and we're putting it into a variable called lightning rune. Now we're going to write all that to the commando.config. This is the file we created earlier in lockdown. It was empty at this point. It's just restricted. It exists. It's restricted to just so you can the only person who can see it. Now it's going to put the values in there. Those are the sensitive values, the rune and the key, the node key. All right. So now it's going to this line, it says truncate one line from commando config, and the reason for that is when you do a here doc like this, it actually puts a new line at the end, but the documentation for CLN application said you need just those two lines and not a blank line at the end. So what we're doing is we're chopping off that blank line at the end, so we have just the two lines. That's just following the setup documentation on GitHub says that that's how the format that this commando config needs to be in. So we're chopping off that extra new line that got added because we used the here doc. Next, we're going to touch the config JSON. So we're going to create that config JSON file, and we're going to lock it down so only we can see it. So we created an empty file called config JSON, lock it down so only we can see it, and now we're going to put the config JSON for this is the config for the CLN application. And the reason we lock this one down is it's going to have a password. When we initially created, we're not putting a password in there, but the first thing, remember, when we loaded up the application says, please enter a new password, right? That password ends up in this file. So That's why we need to make sure this file is locked down so only you can read it. Okay, so this is locked down, and this is just sort of where we start, the config that we start with, and you can change the config layer. Any config changes end up down in this file. So it starts out with the unit of measure is sats, fiat units, US dollars, the app mode is dark, etc. Right? So I just have a few default settings that I've set here, and then as you change those in the UI, it'll just go into this file. Okay, so now we're going to make sure that Node.js is installed. Now, I don't know why I had to add this line. This was a little bit confusing to me because I did remember at the end of the last script I installed Node.js, but whenever I tested this and it got to this step, it said npm command not found. Very strange. So I just make sure this shouldn't do anything, but I'm just making doubly sure that Node.js is installed before I do the next step. So that's all this does, it's just redundant. If somehow Node.js didn't get installed by the last script, it's going to install it now. Okay, so it's make sure Node.js is installed. Then probably I can get away with getting rid of that. I'd figure out why it failed that one time I ran it, but this is just redundant. Anyway, so we're going to now go grab the source code. We have to build this CLN application. You have to build from the source code. So we're going to grab the source code for the CLN application, and that's what we need Node.js for because we're using Node to build this. Okay, we're going to unzip it. We're going to remove the original tar.gz. It's basically a zip file. We'll remove the original archive now that we've unzipped it. We're going to go into the folder that we unzipped it into. First of all, we're going to rename it CLN application. We want the folder to be easy to get into and recognize if you need to go in there and debug or anything. So we just renamed it to CLN application. We go into the CLN application folder, and then we do npm install omit dev. So we're installing this for production. We're not needing the dev installation. So omit dev is what that does. It makes it a production application. So npm install -- omit equals dev. And then remember I had those, I forgot how many it was, 14 or whatever, vulnerabilities. We can fix some of those automatically, so I went ahead and fixed those. The breaking ones I can't fix. I'll put in an issue if there isn't one already on GitHub to make sure the devs fix that. But we fix the ones we can with the npm audit fix. That's what this line does. Then we go into the home folder, which is where we started. We want to make sure we end up back where we started. And then we print out a message that says, hey, the CLN application setup's done. Go ahead and reboot before you try running everything. And so those are the two scripts that we ran. That's what they do. Like I said, verify, don't trust me. Go through and make sure what I'm saying is actually what they're doing. And if you go through there and you are a tech-savvy person, you have looked this, notices any vulnerabilities or issues or ways that I should do this different, please put that in a comment because I want to update these. I want to make sure these are safe for people to run. I believe they are, but if you notice anything, let me know and I'll update them. Or you can put in an issue on the GitHub repository itself. Just open a new issue, or if you're ambitious and want to fix it, you can just put in a merge request on a pull request on GitHub, and I'll look it over. If it looks good, I'll pull it in. So those are a lot of ways that you can help me improve this over time. All right, so that's all I'm going to do with this video. Like I said, next video I'm going to go into a little more next steps, what to do now that you've got this thing running. But this should get you started. I'll see you in the next video.